So here's the vector. The vague idea, vectors do not come out very often, but it's basically, until now, if I pick a point, let's say 5 and 3, then it's really just counting the steps 5 and 3 and then point out, right? But now we're going to use different notation for a connecting line and with an arrow. So vector is something that you have with direction and magnitude. So not only the length matters, where it is matters, but where is it pointing also matters, right? So I could notate this vector now, not with 5 and 3, but because it's connecting 0 and 0, we're going to notate this with this different bracket, 5 and 3. It's basically saying, in x direction, I'm going 5. In y direction, I'm going up 3. And we can notate these by two different vectors. This vector is 5 and 0. This vector is 3, 0, and 3. So this is an x component, y component, x component, y component. And there's another way of writing this thing with I and j. It just has the same meaning that I is simply, in this region, I is this one length right here. 1, 0, or 1i, right? Over here is the other j. So 0 and 1, or we could write j. So whenever you have, whatever number you have, right? Let's say another example would be like some extreme number, negative 17 and 20, right? This thing is really talking about, let's make it short, minus 17 is here, and 20 is here. Then I am picking out this point, and going from the origin, I'm going to make an arrow out of that, right? So that's a vector. Vector is not just a point coordinates, but it tells you where to go, right? So you can think of it as, okay, if I'm going this direction, what about the opposite case? Opposite case would be 17 over here and minus 20 over here, right? So I'm going to be going exactly opposite this way. So this is the vector that you get minus 17, 20, but this is a vector that you get from 17 and minus 20. So you realize that these are exactly opposite side of that, right? Another thing that we can learn is that vectors, you can add them together. So if I ask you, example, vector addition, that if I have somewhat like minus 4, 2, and 1 and 3, let's see what that comes about. Naturally thinking, what do you guys think? If I add these together, I know I'm going to get something like negative 3 and 5. Simply adding these numbers component-wise, right? Let's see that that's true on a graph. So when you're adding vectors, I want you to think of it as, okay, it's two sides of parallelogram, and I'm going to make a diagram with it, right? I mean, diagonal with it. So let's go from minus 4 and 2. So 1, 2, 3, 4, 1, 2. We have a point right there. It's going to stretch out this way. Okay? 1 and 3. The other one, it's going right here. Okay. And what was my resultant vector? It's negative 3 and 5. It's going up from here, 1, 2. So we will go over here. And as I said before, I want you to think of this as two sides of parallelogram. So I am going to make parallel line with this line from here. So if I draw it well, it should touch right there. Okay, so we have this thing right there, 3, 4, 5. Okay, this is going that way. We're gonna make another parallel line from here to this, so we get this kind of point. Okay, This point right there is supposed to be 5, so